In exercise 4, we have Barney depositing $1,000 into Bank X on January 1, 1998, at a rate of interest I, which we're not told what I is, per annum, which means per year, so it's a nominal rate, and it's compounded quarterly. So we have to do our timeline in quarters. So we started with 1/1/98, and then the next one would be April 1/98, July 1/98, etc. We're going to see this through to January 1, 2006. So I have my timeline going all the way down to January 1, 2006. And I don't know I, so I'm going to start with a guess for I. And I'm going to take that initial deposit of $1,000 and add interest, so multiply by 1 plus I over n is 4, to get the balance at the end of the next quarter. So that formula gets copied down. Now on January 1, 2003, he transfers his account to Bank Y, where he earns a different interest rate, J, but again compounded quarterly. So we don't know J, so I'm going to let J be a guess for now as well. And so the peach cells are ones where I've used J to compute the interest. So I multiply the previous balance by 1 plus J over n to get the balance at the end of the next quarter, and that gets copied down all the way down to January 1, 2006, and I end up using these two guesses for I and J with $1,000, 444 and 63 cents. Now, if we're supposed to end up with $1,789.94. So if Barney could have earned interest at rate J for the entire period, then his balance would have been $1,995.53. Okay? So in column C, I'm starting with the same $1,000, but I'm multiplying by 1 plus J over n for the entire 8 years. Okay? And I ended up with 1374.94, so my guesses are obviously not correct. So I'm going to use my my solver to find I and J. So my objective is to let B34, so this amount, equals 1789.94, because that's what I want to end up with under the first scenario. By changing H4 and H5, that's where I have the I and J. And then I also want 1995.53 for the ending balance in column C, so I'll put that as a constraint, that C34 should be 1995.53, and then I'll ask it to solve, and it finds a solution, and we can see that I is 6.514% and J is 8.73%, and the question asks for the ratio of J to I, so we can compute that ratio. It's 1.34017.